Hi and welcome. In this video, we will introduce the logarithmic expressions. Let's start with the problem statement. Suppose y is b to the power x, where b is positive and not equal to 1. In this equation, if we have x, we can easily calculate y by simply raising b to the power of x. But what if we have y and want to find x? To find x, we need to inverse the operation, which is called the logarithm. In other words, if y is equal to b to the power x, then log base b of y is equal to x. As you can see in these two equations, in the first equation, if we have x, we can easily find y by raising b to the power of x. In the second equation, we can find x if we find the log base b of y. In other words, in the first equation, we have x and we want to find y. Then we use this exponential equation. In the second equation, we have y and we want to find x. Then we use the logarithmic equation or operation. Remember that b is positive and not equal to 1, which is the base in both equations. For example, we know that 8 is 2 to the power 3. Therefore, the log base 2 of 8 is 3. Remember that 2 remains the base in both equations, both in the logarithm and the exponential expression. Logarithm of base The logarithm base 10 of 100 is 2 because 100 is 10 to the power of 2. Likewise, the log base 2 of 1 over 4 is minus 2 because 1 over 4 is 2 to the power of minus 2. Using the properties of exponential expressions, we can deduce the properties of the logarithmic expressions, such as log base b of 1 is 0 because b to the power 0 is 1. Log base b of x times y is equal to log base b of x plus log base b of y. That is, this multiplication is transformed to summation. Log base b of x over y is equal to log base b of x minus log base b of y. Log base b of x to the power m, this m moves at the front of the logarithm, and it becomes m times the log base b of x. Log base b to the power n of x, this time n is the power of the base. Again, we can move this power at the front of the logarithm, but it becomes the reverse of that number, is 1 over n log base b of x. And finally, log base b of b itself is 1. For instance, log base 3 of 1 is 0. Log base 2 of 8 is equal to log base 2 of 2 times 2 times 2 because 8 is 2 times 2 times 2. Then using the second property, we can write log base 2 of 2 plus log base 2 of 2 plus log base 2 of 2. And using the last property, we know that this is 1, this is 1, and this is 1, therefore we get 3. Log base 5 of 25 is equal to log base 5. 25 we can write as 5 squared. We can move this power at the front. This is 2 times log base 5 of 5. And we know that log base 5 of 5 is 1. 2 times 1 is equal to 2. Likewise, log 1 over 3 of 27. We can write 1 over 3 as 3 to the power minus 1 and 27 as 3 to the power 3. Then moving both powers from the base and from the number at the front of the logarithm, we get 3 times the log of 3 to the power minus 1 of 3. Now we move this minus 1 at the front of the logarithm, it becomes 1 over minus 1, which is minus 1 here, log 3 of 3. What we get is 3 times minus 1 is minus 3, Log base 3 of 3 is 1, minus 3 times 1 is minus 3. Log base 3 of 3 over 27, using the property here, property number 3, we can write that log base 3 of 3 minus log base 3 of 27. The first logarithm is obviously 1 because that is base 3 of 3. The second one, we can write 27 as 3 to the power 3, then moving this power at the front, we get 1 minus 3 times the log of base 3 of 3, which is again 1 times 3 is 3. 1 minus 3 is minus 2. Practice for you, simplify this. Log base 5 of 1 over 5 plus log base 3 of 1 over 27. Log base 10 of 1000 minus log base 2 of 1 over 2 plus log base 1 over 3 of 81. Thanks for watching and good learning.